In statistics, probability sampling refers to the selection of a sample from a population based on the principle of randomization. So we can use the information to make judgment or inferences about the population. Compared to long probability sampling, probability sampling is more complex, more time-consuming, and usually more costly. However, because units from the population are randomly selected and each unit's selection probability can be calculated, we can conduct more reliable estimates and make statistical inferences about the population. There are many practical reasons why we prefer to select portions or samples of a population to observe and measure when studying characteristics of a population. For example, it is too time-consuming to contact the whole population, such as surveying the whole population of the USA. Even if time is not a problem, it could be too costly to study all population. For example, finding all potential consumers' preferences of smartphones. Sometimes it is physically impossible to check all items in the population, such as fishes in the Pacific Ocean. Finally, some tests are destructive, such as some medical tissue type tests. In this video, we will introduce 4 major probability sampling approaches, namely simple random sampling, systematic random sampling, stratified random sampling, clustered sampling. A simple random sample is meant to be an unbiased representation of a group, in which all members of the population have a chance of being selected for the sample. If the population is relatively small, one could place all the items of interest, say names, in a box and select the sample. For large samples like the one in this example, it is very time-consuming. In this example of selecting 10 players out of the 750 Major League Baseball players, we may prepare a list of all the players and number them 1 through 750, and then randomly pick 10 numbers between 1 and 750. Another way to select a sample is to use a table of random numbers, like the one we show here, or to use a statistical software program or Excel to select a simple random sample. This example shows how to select random numbers using a portion of a random number table. To choose a starting point, you could close your eyes and simply point at a number in the table. Another way is to randomly pick a column and a row. Suppose the time is 3:04. Go to column 3 and down to row 4. Here, the number is 03759. So we use the first 3 digits in the 5-digit number. To continue selecting, you could move in any direction. In this example, we move right. The next number is 44723. So we choose player 447. The next number is 961, and it is too high, so we skipped it. And we skip the next number, 784, because it's also too high. Then the next number is 18910. So we select player 189, and so on, until we have a list of 10 players. Simple random sampling is not an effective method for some scenarios. For example, Stuart's grocery market needs to sample its customers to study the length of time customers spend in the store. Practically, however, we cannot list the population of all customers. So assigning random numbers to customers is impossible. Instead, we can use systematic random sampling to select a representative sample. Systematic random sampling is the random sampling method that requires selecting samples based on a system of intervals in a numbered population, such as every kth members of the population. One simple example of systematic random sampling is to select every 100th listing in a telephone book after the first randomly selected listing. Using systematic random sampling for Stuart's grocery market, we decide to select 100 customers over 4 days, Monday through Thursday. We will select 25 customers a day and begin the sampling at different times each day. For example, 8 a.m., 11 a.m., 4 p.m., and 7 p.m. We write the 4 times and 4 days on slips of paper and put them in 2 heads. One head for the days and the other head for the times. We select 1 slip from each head. This ensures that the time of day is randomly assigned for each day. Suppose we selected 4 p.m. for the starting time on Monday. Next, we select a random number between 1 and 10. It is 6. Our selection process begins on Monday at 4 p.m. by selecting the 6th customers to enter the store. Then we select every 10th. That would be 16th, 26th, 36th customers until we reach the goal of 25 customers. Systematic random sampling has the properties of a simple random sample, especially if the list of the population element is a random ordering. The sample usually will be easy to identify than it would be compared to the simple random sampling. It is worth noting that if the population is in some order already, like invoices arranged in increasing dollar amount, the systematic procedure should not be used. Stratified random sampling is a method of sampling that involves dividing a population into smaller groups called strata. And a sample is randomly selected from each stratum. The groups or strata are organized based on the shared characteristics or attributes of the members in the group. The process of classifying the population into groups is called stratification. The basis for forming the strata can be department, location, age, industry type, and so on. Intuitively, if strata are homogeneous, stratified random sampling will provide a result that is as precise as simple random sampling, but with a smaller total sample size. In this example of using stratified random sampling, 352 largest US firms at spendings have been grouped by profitability, measured by the percent return on equity, into 5 strata. About 2% of population are in stratum 1, 10% in stratum 2, 54% in stratum 3, 33% in stratum 4, and 1% in stratum 5. In this special scenario, if simple random sampling is used, observe that firms in the third and fourth strata have a high chance of selection, that is, probability of 87%, while firms in the other strata have a smaller chance of selection, that is, probability of 13%. We might not select any firms in stratum 1 or 5 simply by chance. However, stratified random sampling will guarantee that at least one firm in each strata 1 and 5 is represented in the sample. Let's say that 50 firms are selected for intensive study. Then, based on probability, one firm, or 0.02 times 50, should be randomly selected from stratum 1. We would randomly select 5 or 0.1 times 50 firms from stratum 2. In this case, the number of firms samples from each stratum is proportional to the stratum's relative frequency in the population. Stratified sampling has the advantages, in some cases, of more accurately reflecting the characteristics of the population than does simple random or systematic random sampling. In cluster sampling, researchers divide a population into smaller groups known as clusters. They then randomly select among these clusters to form a sample. Cluster sampling is a method of probability sampling that is often used to study large populations, particularly those that are widely geographically dispersed. Use cluster sampling can be cost-effective because the elements are in close proximity to each other, and observations can be collected in a relatively short time. The disadvantage is that cluster sampling generally require a larger total sample size than simple or stratified random sampling. In this cluster sampling example, we wish to determine the views of residents in the greater Chicago area about state and federal environmental protection policies. Selecting a random sample of residents in the region and personally contacting each one will be time-consuming and expensive. Instead, let the counties serve as the primary unit and select a random sample of the counties. For example, randomly select 3 counties, the green ones, out of the 12 counties. And then in each of the selected county, we select residents in a simple random sampling. This is a combination of cluster sampling and simple random sampling. We now talk about the differences between stratified sampling and cluster sampling. The first main difference between stratified sampling and cluster sampling is that with cluster sampling, you have natural groups, geographic, or other boundaries separating your population, such as city blocks, voting district, or school district. With stratified random sampling, these natural blocks may not exist, but you divide your target population into strata in terms of a certain characteristic. The second main difference is that in cluster sampling, the first stage sampling unit is the whole cluster instead of the sampling individual from within each group, like in stratified random sampling. Although in the second stage of the sampling, cluster sampling also randomly draws samples from the selected cluster. We now summarize the content that we have learned in this video. In specific, we have learned 4 major different types of probability sampling approaches, namely simple random sampling, systematic random sampling, stratified random sampling, cluster sampling. Good luck on the practice quizzes. Thank you.